I'm Anil Kumar, and here is a question from the test paper on Introduction to Calculus. I have selected the questions from the test paper so that you learn something more and you are far better prepared for your own test. The question here is, explain why the function f of x has a discontinuity at x equals to 1. How must f of 5 be defined to make the function continuous? You are given the function f of x equals to x squared minus 2x minus 15 over x minus 5. You can pause the video, answer the question, and then look into my suggestion. Now, what I observe in test papers is that some of the students will jump to conclusion and they say, well, the function is discontinuous at x equals to 5 because of vertical asymptote, since x minus 5 is in the denominator. Well, that will be wrong. So don't jump to the conclusions immediately. Try to think a bit more. The numerator can be factored. Let us factor this, and then what do we get? So we are looking for two numbers whose product is minus 15 and sum is minus 2. So those could be x minus 5 times x plus 3 will give us that factoring, and that gives us x minus 5. Now x minus 5 is the common factor in both numerator and denominator, so it could be cancelled and we get x plus 3, and this expression is equivalent to the given rational expression, and we have to write x is not equal to 5, correct? And now it clearly indicates what type of discontinuity we are talking about. Since we have a common factor in numerator and denominator, here the discontinuity is a whole, right? At x equals to 5 is a whole, right? So that is how the function is. Now if you sketch a graph of this function, definitely you'll get a straight line, which is x plus 5, x plus 3, and at 5 there will be a whole, right? So if I say this is a positive slope, right? Okay, so that is my line. So this point is 3 for us. So in this line at 5 we have to make a hole, right? If you don't make this hole, then it is not correct representation, right? So this is what it is. So basically we have a hole, and I should have drawn it in a lighter color. So actually speaking, it is this part, right? So there is a hole in between, so that is the discontinuity, right? So we're talking about this hole at x equals to 5. Now the second part, so we have answered the first part. Now let's look into the second part. It's indeed a very good question, and it gives you concept about continuity. How must f of 5 be defined to make the function continuous? So what we can do is we can define this as a piecewise function, and that is why when you are studying about piecewise functions, you have to check for continuity. But if you see in the functions in the chapter on continuity, you are actually talking about piecewise functions, right? Most of the time. Okay, anyway, so this is how you should be defining your function. So we have the given function, and you should say this is when for all x values but not for 5. And then for 5 you can write the value. If I substitute 5 here, I get 8, right? So write and is equals to 8 when x is equal to 5. In that case, if I do this piecewise function, then I fill it up, right? So if I fill it up, it becomes continuous. So that is how you can redefine your function by plugging in the hole, right? Since the type of discontinuity was a hole, it could be plugged in. So that is kind of important, by defining another function which is valid for x equals to 5 in this particular case, correct? I hope that helps you to understand in better depth the chapter about continuity. Thank you and all the best.